Let's move forward. Now we will go through the basic fundamentals of this field, okay, and we will try to go through a little bit of understanding, okay. Implementing security is a completely, you can say it's a continuous process. Security is just not like you have implemented something and you just forget about it. It is okay, and you don't have to do anything in future. Okay, it's not like that. Security is something which is a continuous process. You need to continuously predict, prevent, detect, and respond. Okay. This is a framework. This is the cybersecurity framework which is provided by the NIST, which I have told you earlier also. So NIST has provided a framework which should be taken care or should be followed while you are implementing the cybersecurity. Okay. This framework contains 4 parts, which is predict, prevent, detect, and respond. Okay. The cybersecurity framework consists of standards, guidelines, and best practices for managing the risk associated with the cybersecurity. The priority-based, versatile, and cost-effective approach of this framework, okay, it helps you to implement what is critical to your infrastructure. Okay, so this is a very general framework. It could be used in any field, be it the web designing, be it the web security or database security or your automotive security. It is a general framework which is followed majorly everywhere. Okay. Now, if you talk about the center of this framework, the main concept of this framework consists of the 5 functions, which is majorly your identifying, defending, detecting, reacting, okay, and recovering. So you have the predict, prevent, detect, and respond. Okay. Now, the framework offers a set of cybersecurity outcomes under these umbrella roles, okay, based on the existing principle, guidelines, and the procedure that company can tailor. So it gives literally it gives a guideline, okay, and then based upon the requirement and needs, company can change those methods and utilize it into their infrastructure. Okay. It says simply that you need to start with your system design in such a way that you could predict what could happen. And depending upon those prediction, you need to implement the countermeasures in the starting only. Okay. But these when your product will go into the market, it should prevent these attacks. Okay. But it is not possible to detect everything now. So detect, or you can say prevent everything. But your system should be able to detect the attacks or the threats which has been realized. Okay. Detecting means you can say implementing an intrusion detection system. It could be a method of detection. Okay. So once you detect, there should be a possibility to respond and recover. So recover and respond in this 5 the things which I've told you. The respond and recover are in this single block. Okay. So you should be able to respond immediately, and we should be able to recover it. Okay. Now, once you will be able to recover it, again this cycle starts, and you need to predict it again. Okay. Now, prediction here means you have identify again a vulnerability. Practically, when you implement this framework, as I told you, when you identify the vulnerability, again you need to start predicting the related threats. So when you have identified one vulnerability, it could be possible that there are other vulnerabilities related to it. Okay. The complete picture you need to predict and study. You need to again perform the threat and risk analysis in the predict phase. Okay. And you need to identify the requirements which need to be implemented. Then those requirements again need to be implemented, and those requirements should prevent any type of attack. First thing, in case, again, if there is something which is not implemented and you have not considered it into your predict phase and you are not able to prevent it, at least you should be able to detect it again. And once detected, then you should be able to respond. And again, this cycle keeps on going. Okay. This is which is followed in most of the industry. In cybersecurity, generally, this is a framework which is followed, and this is provided by the NIST. Fine. Now, let's move on further, and here we will try to understand that in a layered way how you implement the security aspects of the in a vehicle. Okay. So you have the outer surface is your secure external communication, where vehicle is communicating with the external world. Then you have the secure gateways, secure in-vehicle communication, and your source platform. Okay. Let's understand this in the perspective of a vehicle, that where all those things, all those layers are implemented. Okay, so first layer is your secure communication or secure external communication layer. Fine. This is the layer which is securing the communication with the external world. Okay, so all those cloud communication and any type of communication with the mobile phone or the vehicle to the infrastructure communication, everything you need to implement your security at this layer. Okay. Then for the second layer of communication, when your data which is coming from the outside world, it is going into the internal network. So there is a gateway which is called the gateway secure gateway ECU, which is placed here, and this has the property of controlling the traffic. Okay, detect the malicious traffic and data security and privacy. So it implements all your intrusion detection system, firewall, intrusion prevention system. Everything has been implemented here to make the internal network secure from the external world. Okay, so this isolates the internal network from the external world. Now, coming to the internal network, the thing is your network, which could be your Ethernet network or your CAN network. Okay, so it should be important to secure this internal communication or the data which is flowing, messages which is flowing over this network. Okay, how you do it? You implement the authentication, confidentiality, and the integrity of the messages, and then you also manage the keys within this system. So there is a key management system that need to be implemented, and using this key only you can create the CMAC, or you can implement secure communication. Okay, secure onboard communication defined by the AUTOSAR also. Okay, in this network, the last and the most inner layer is your secure platform, which are basically your ECUs. Okay, and what are the security aspects or security measures, countermeasures that you need to implement in your ECU? This is your core. Okay, and here you implement basically your crypto library. So your all the AES algorithm, public key cryptography, everything that you need to implement here. Okay, your secure boot, remote attestation, secure update, hardware trust anchor. So this is one of the major and important player into this automotive cybersecurity. Okay, most of the tier one work over this. OEM take care of this complete vehicle. Okay, so these are the ECUs on which your tier ones are working. So like body control module, infotainment system, instrument panel cluster, your secure gateway. Okay, so these are the things which are implemented at this level. Fine. So I hope it would be clear to you about this layered approach. And this layered approach is very generalized approach, which is followed by all the OEMs. Right now, this is the approach which is followed majorly in the automotive industry. Okay. Let's go one by one into each. So let's start with the secure external communication. Then we will try to understand the secure gateway. Then we will go to the secure internal communication. And then we will discuss about this secure platform. So secure boot or secure update. Okay. Not going into very deep, but we will have a high level overview. Okay. So when you talk about the secure external communication, your vehicle is communicating either to the infrastructure or to the manufacturer, like they will implement a plan. So if they need to update the software in the vehicle, they will communicate the vehicle. Then future technologies are vehicle to infrastructure, vehicle to vehicle, or infrastructure to vehicle. So your roadside units will be communicating with your vehicle, or the government agencies will be communicating through your vehicle. So there are some standards which are defined, like IEEE 1609.2, 1609.3. 1609.2 is the IEEE standard for wireless access in the vehicular environment. So the security service for the application and the management messages. This standard basically defines secure message formats, okay, and processing for use by the wireless access in the vehicular environment. It is called the WAVE. Okay, this is the general term is WAVE, which is the wireless access in vehicular environment. Okay. Now this includes method of securing WAVE management messages and methods to secure the application messages. Okay, so this particular standard contains all those things. Then you have IEEE 1609.3. So 1609.3 is also related to the WAVE, okay, which is your wireless access in vehicle communication. It works over your I think layer 3 and 4. Okay, so of the OSI model, if you see the OSI model, it will work. It will working over layer 3 and 4. Okay, so your internet protocol, your UDP, user datagram protocol, and your TCP. Okay, at this layer, this particular as IEEE standard will work. Okay, and then you have your cellular network. So it could be possible that manufacturers or the OEMs are using the cellular network for communicating with the vehicle. On the other side, you will have the Wi-Fi network could be employed for working with the for short distance. So uh, if the vehicle need to communicate with the roadside infrastructure, then it could directly communicate with the Wi-Fi. Okay, to implement a secure communication between the manufacturer vehicle and the infrastructure, there is a methodology which is called the PKI, public key infrastructure, which is used, which uses a certificate from a certificate authority of the government if it is communicating with the government, infrastructure or the roadside infrastructure, and if it is communicating with your manufacturer or the OEM, then a certificate authority will be your of the manufacturer. Okay, so they provide a certificate, and this certificate contains your public key, and using this particular certificate, this communication happens. This secure communication happens. Okay, so this was related to your secure external communication. Now we will talk more about the secure gateway. Okay, now secure gateway is becoming one of the major key issue in the present vehicle, in the present and the future vehicle, because it is the vehicle, as you have seen into the first picture of the layered architecture. This is the ECU which directly communicates, or which is the first ECU which communicates with the external world, and it is responsible basically for securing the internal network from the attacks or from the threats or malicious activities of the external world. Okay, so this is the ECU which takes all the responsibility. It could be possible that you implement firewall, you implement the key infrastructure, crypto primitives, you have the intrusion detection system, you could implement the secure flash, secure boot, then secure synchronized time manager. So PTP protocol could be implemented, and the download manager for the ECUs, which is the internal network. So if FOTA is used, then this FOTA content will first come to your secure gateway. Secure gateway will authenticate it, then only it will allow you know to go through it, and then your ECU could be flashed. Okay, so this particular secure central gateway will be this secure gateway is basically could be divided into two parts, which is the central gateway and the connectivity gateway. Okay, so this picture that you see defines what are all the properties which are implemented in the central gateway and the connectivity gateway. Okay, so connectivity gateway could have the property of or could have the functionality of the download manager also. Okay, and then this synchronized time manager also, because it need to receive the data, and then it need to provide it to the other ECUs for flashing good. Okay, so it could have these two. Central gateway is more related to securing the internal network. So it will have your intrusion detection and prevention system. It will have your all firewall and key infrastructure, crypto primitives, and everything will be here. Okay. Then it will also create your logging. So secure logs are also done here. Fine. So this is the central gateway, and another will be the connectivity gateway. On the other side, so if you see, this central gateway has divided the infrastructure, or you can see the network of the vehicle, into multiple parts. So now the powertrain ECU will not be connected to the instrument panel cluster directly. They will go through this particular secure gateway or the central gateway. Fine. So no ECU will be connected directly to each other. All the data which is flowing over the network need to be authenticated by this central gateway, and then it could be communicated, or it could be passed through it and will be received by the other ECU. So all the data need to be authenticated, and then only it is considered for some sort of action that need to be performed in the vehicle. Fine. So this is majorly your secure or the central gateway. Moving toward the secure internal communication, that is your key management system. Now, if you employ the public key infrastructure and you have your private key and public key which are being used, this infrastructure basically used for the secure update, flash over the air, or communication with the cloud in case if some new functionality need to be added. Things like these are done, using this public key infrastructure. Okay. Now, in your vehicle, you could have a key management system, employed, which manages the key. So let's say your ECU need to communicate over the network, and on each message which is coming out and going in into the ECU will have a CMAC attached to it. Okay. Now to sign or to provide this CMAC, you need to have a key attached with it. Okay. It uses the symmetric key cryptography, the MAX. Okay. So you need to have a key. How these keys are managed, how these keys are distributed, this is the responsibility of the key management system. Okay. It could be possible that there is a completely different ECU which will be managing the keys, or each ECU will have its own key management system synchronized with the central gateway, and gateway will act as a master. It will provide the directions to all the ECUs regarding this key management methodology. Okay. So anyhow, it will have your root key, then it will have your sub keys, and then the leaf. Okay, these leaf keys are basically used for the communication. And this particular chain, it is called the chain of trust. This particular chain of trust is used to authenticate the leaf keys. Okay, and in case if this particular or any of the leaf key is compromised, then they need to be revoked. So there is a particular this is all the responsibility of the key management system, that how it need to discard a key and to generate a new key, or it need to save a new key. So in case if the public key is imported into this ECU from the OEM directly, then it need to securely take the keys and secure it into a secure memory area. Now this is all the responsibility of the key management system. Okay, so moving further, let's talk about the secure platform, which is secure boot and remote attestation. Now, secure platform, as I told you, is related to individual ECUs. Okay, where you are implementing your secure boot, secure update, and then you are implementing your cryptography there. You will have your HSM hardware security module also into this ECU. Okay, so it is a complete computer which need to be safeguarded. Okay, so you need to implement everything there. Talking particularly about the secure boot. Secure boot is something that when your system, these ECU, it starts, it doesn't start directly your application. Okay, first it goes into the boot mode. This boot mode, first of all, authenticates your application. Okay, it will authenticate. It depends upon the number of levels that you have implemented. So sometimes you have your boot manager. So first will be your default host boot, then your boot manager will be there. Boot manager will authenticate the boot loader, and boot loader will authenticate the application, and then application will start. Okay, so this could be a possible way of implementing. Okay, so this host boot that I'm saying, which is the first or default boot, it is the you can say microcontroller default boot. So if your system starts, it will first start this default boot. This default boots authenticates your boot manager. Boot manager then in turns it will give command to the HSM to authenticate your boot loader. Okay, so it is the boot manager and everything will be into your you can say host CPU area. In the present microcontrollers, if you have the idea, they have two cores. One core is the host core. It is called the host core, which is responsible for running actual applications. Okay. Then second core could be there, which is called the HSM or hardware security module. Okay. So this hardware security module runs all the crypto systems, all the crypto services, such as your AES algorithm, verification, CMAC, and everything need to be implemented in your host, in your HSM side. Now your boot manager and everything is in your main core, which is your host, and whatever need to be authenticated, a command need to be sent to the HSM side, and corresponding to these commands, the action is performed, whether it is to verify or to generate the CMAC or anything. Whatever be the command, the HSM core will perform that action. Okay, so you can imagine it in a way that your microcontroller has two different CPUs. One CPU is basically performing all the actions, opening the window and all those functionalities which your vehicle have. The first core, the host core, will have all those functionalities, and the second core is basically responsible only for the crypto services. Okay, it will provide you the services for verification, for the key generation, for MAC generation, and everything need to be provided by this. So in this way, they communicate. So your boot manager will send a command to your HSM core to authenticate your bootloader. And now this particular HSM core will authenticate or verify the bootloader and just send OK or not OK. Okay, depending upon this result, which is OK or not OK. If it is OK, then your process will again go further, and your bootloader will ask this HSM core to again authenticate your application. And in this way, your application is authenticated. And once it is authenticated, it starts running. Okay, so actual functionality of the vehicle comes into picture after this. Fine. This is one method. There are many other methods which are employed. Okay, you have the primary boot, secondary boot. Many possible methods could be there. Okay, depending upon the requirements. So this is just a very simple method that I have informed you. I've told you. And the secure boot, it is basically one of the practical methods which is implemented into the ECUs. Okay, so this is what is actually implemented. So now moving further, we will talk about now the secure update. So boot is something when you restart or start a system. Okay, so the booting takes place. Update is related to again or reflashing the software into the ECUs. Okay, so how this reflashing take place? There are certain conditions that need to be met into the vehicle. For example, the condition could be that vehicle could be into the static state. It should not be moving. The brake should be pressed or something, or the handbrake should be pressed, something. It could be possible. I'm just telling you a vague uh, something which could be a possibility. Okay, so its RPM should be this much, or its speed should be this much. It should be connected to a secure network or a Wi-Fi, something like this. Okay. Once all these conditions are met, okay, then your OEM has the responsibility to securely transfer the code to your vehicle. Okay. Now, when you talk about securely transferring the code, it means that your vehicle and your OEM or the OEM server will have a public key infrastructure built between them. Okay. So your OEM will have the code. It will first of all encrypt the code and create the sign. Okay, do the signing of the code. Once this data, which is your code and your code sign, has been generated, it is passed to the vehicle. When vehicle will receive it, it will verify it using the public key which it has been received from the security server. Okay, so certificate verification is done. So it will use this public key to verify, and it will again it will verify the code sign. Once this code sign will be matched, then it will understand, okay, this is an authenticated data which need to be flashed, and then it will start the flashing procedure. Okay, if this security verification fails and in this sign doesn't matches, then the update will never be done. Okay, and the vehicle will restore its previous application and it will keep on running. Okay, this is a very high level view of how the secure updation is done. Okay, there are much complexity beside this. How tier one generates an binary, and then it passes that binary to the OEM. OEM performs the signing and all those things need to be done. Okay, and then it should need to be transmitted to the in a secure way to the vehicle, and then vehicle flashes. So all those things are very complex. Okay, but in a very simple way, we just need to understand that the data, which is your binaries, are sent with a code sign, and this code sign need to be verified inside the vehicle. Once this code sign is verified, then only the data which is being received, whether it is encrypted or it is in the plain text format. Generally, the encrypted data is sent, so it need to decrypt it and then it need to flash. Okay, this is how it works. Okay, so now moving further, we will now go through a simple demo and a case study. When I'm talking about a case study, it means that when I start working over an ECU and I start looking over it, what could be the possible threats of an ECU, how I do it, okay, how I identify the attack surface, how I identify the damages which are related to the attack surface and what could be the possible methods. Okay. Now, from these damages, actually, your impact is identified. What could be the impact? On the other side, you have the threats and everything from which your feasibility is identified. Okay, how feasible it is to do this attack, and using this impact and feasibility, you determine the risk rating. But in this, we are not going in that deep. We will just try to understand the attack surface, the attack methods, and the damage scenarios. What could be the possible damages that could happen? Okay. Before going into the case study, there are some terms and abbreviations that we need to understand. So I will go through those points just for your better understanding that what we are talking about. Okay. So the question comes here that how attackers get trained. Okay, so this is what I'm trying to identify, that if I have an ECU, then how an attacker could get it. Okay, the first thing that I need to identify is the attack surface. Okay, attack surface is a point which the attacker could exploit. Okay, so it could be anything. It could be your wireless communication. Protocol. It could be your USB port. It could be your the multimedia playback, or your external diagnostic interfaces. It could be your application also. So attack surface could be anything. In a simple terms, if you say an attack surface is a set of points or a system elements whereby an attack can potentially breach, affect or control system, extract or manipulate the information. Okay, that is the definition of the attack surface, the formal definition of the attack surface. Fine. So in more detail, if you say, then attack surface are often referred to as the digital footprints. This is just more fancy term. So digital footprint. So what it consists of the thousands of assets. Assets are something which is valuable for you. That is you call the asset. No, maybe your wallet is your asset. Okay, that is valuable for you. If it is being stolen, much of the data which is personal to you, your money, you will have a financial loss. You will have a personal information loss. Many things could be lost. No, so this is an asset for you. Similarly, an attack surface could be related to the assets. So if an attack surface is compromised, your assets could be compromised. Okay, it contains the components, externally controlled information system like your internet infrastructure, millions of signals across the public and private cloud environment, and then organization, brand, social media, and the mobile system. It could be anything. Okay, so if your attack surface is compromised, it could be this means your security system has failed. In some way, your security system has failed if attack surface has been compromised. Okay. Now, designing a secure automotive product is something which is the basic of developing a product, developing a secure product. And when you say this secure by design principle, okay, secure by design principle is all about predicting every kind of threats that could be possible to your system and try to implement the security measures. Okay, but it is for sure it is not possible to identify all the threats to your system. So what need to be done is that you need to implement also a intrusion detection system. Let's say, okay, you need to implement an intrusion detection system. Now this ISO 21434 is basically the standard which has been defined. And it is previously it was SAE J3061, which was the guideline. But over this guideline, this standard has been defined by the automotive industry, and this ISO is basically followed in all the OEMs, Tier 1, and in complete automotive industry. This ISO is followed. Okay, and this ISO defines a method of threat and risk analysis that need to be done in the starting phase. Now, what we are going to discuss right now is a part of threat and risk analysis, that you define the attack surface, and then from the attack surface you identify the damage. Okay, then there are further things that need to be done in the threat and risk analysis. But for now, we will only understand the attack surface and the your damage scenarios. Okay, let's just directly, I think, jump to this discussion. Okay, identifying the attack surface. Okay, Now, let's say you have this vehicle, and within this vehicle, you have this network infrastructure, okay, where you have the central gateway, and then you have in-vehicle infotainment system, ADAS in one module, then you have the other modules. And like this, the central gateway is dividing the complete network into the different modules, okay. And let's take this particular network into our consideration.